आप ही मतलब आईडी कार्ड लगा
अरे अरे प्रोजेक्टर स्क्रीन डा
ये स्क्रीन का क्या होगा डेटा हो गया
Hello.
Microphone. Hello.
AICTE.
Bapak कर रहे
Kapan nih? Delay.
हेलो Microphone. नॉइस है ना
Noise नहीं है, उस साइड में ज़्यादा noise है, इस साइड में
तो इधर से नहीं बोलो
ठीक है अभी.
हाँ अब जा रही है अरे वन तो करो
हाँ
अभी नॉइस इतनी है
नहीं ठीक है, थोड़ा कम हुआ.
थोड़ा कम
ये हम कुछ नहीं कर सकते, माइक का प्रॉब्लम है, फादर का प्रॉब्लम है.
नहीं हम कर सकते हैं तो टेप मार देंगे
राजेश, ये सब करना फर्स्ट सेशन के बाद लंच के दौरान, बीच में भी मत करना। उसके अंदर करेंगे ना ये रजिस्ट्रेशन लेना तो लंच में अभी उठती हो अभी मत करो, बीच में कोई डिस्टर्बेंस करना है। जितना वो प्रोफाइल खोलिए, ओपन करना डायरेक्टली। राजेश, यहाँ एक क्लास
सर मैं बोला हूँ आ रहा है वो सर।
ओपन करो जरा, मैं पढ़ती हूँ, मैं कि पढ़ूँ पढ़ी। बाकी नहीं आएगा तो फिर कभी भी नहीं आएगा, मतलब क्या करते हैं। तो टेक्नो वगैरह कहाँ है?
टेक्नो का 2 आया बस, वही रेड शर्ट और
फैकल्टी भी नहीं आया वो सर का जो पीपीटी भी डाउनलोड करो तो इस पर
वही कर रहा हूँ सर। सेम पीपीटी है ना?
तो गन फॉरवर्ड की थी मेरे व्हाट्सएप पे, वो कर दो ना। तो पहले से करना चाहिए यार, मैं आया होता सोचे सर भी यहाँ खड़े रहेंगे।
नहीं, मेरे
तो
पेन
क्या
ड्राइव पे था
है, इनका
सर।
रजिस्ट्रेशन ये इतना इम्पोर्टेंट नहीं है सर, ये बाद में भी हो सकता है।
सर मैं जस्ट पेपर दिया था।
और वो उसका पेपर का भी फोटो कॉपी कराना, वही बाद में कराना है उनको, जब टीम ही होगी ना तब कराना, बीच में उठ के नहीं जाना, सब लोग यहाँ रहेंगे, है कि नहीं। जो भी प्रिंट आउट लेना, पेपर लेना, रजिस्ट्रेशन, तो बाद में भी कर सकते हैं। जो लोग आ गए वो कैन डू इंटायर डे होता है। सेशन कम से कम पहला स्मूथली होने दीजिए।
ओके
पीपीटी आ गया, कहाँ है दिखाओ जरा। और उनका सर का प्रोफाइल।
एक सेकंड।
ये भी पीटी है, और वो सर का वो दिखाओ जरा। ये इनको अपने पढ़ने दो। सर मॉर्निंग सर, वो श्रीवास्तव सर आ गए थे सर, बैठे थे, मैं आपका इंतजार कर रहा था। कितना टाइम लगेगा सर? अच्छा आ जाओ। हाँ ठीक है, हाँ जी सर, प्लीज़ सर।
विक्रम सर है?
वो ही नहीं आया
ओके विक्रम सर शायद अमिताभ को लेके वो लेके आए, स्वीट्स वगैरह लेके आए हैं। Everybody sit.
Morning.
हाँ कर दिया सर।
आज सुबह ना?
हाँ सर दूसरा कर दो।
मैं सुबह
हाँ बोल नहीं आप सुबह नहीं कल जो
नहीं
अच्छा आपके राजेश किस नाम से
दो ही है भाई, PDF है PPT।
एक तो कौन सा PDF करेंगे PDF वाला कर दो, वो पूरा पुराना वाला हटा दो सर का प्लीज शट डाउन।
अरे भाई इस चेयर में केबल खोलना।
सर ये दो सर आ गया।
अरे नहीं
नहीं सर वो यूज हो गया।
वो तो चल रहा ना
मत हिलाना।
तो राजेश सीट ले लेना जैसे मेन बात करना।
इसका
अब वो इनका प्रोफाइल अभी रख दो, कोई बात नहीं।
गवर्नमेंट ठीक है
Good morning everyone. Now we are going to start the first session of the last day, and with immense pleasure I would like to say that we have with us Dr. S.C. Srivastava, Professor IIT Kanpur. Sir is a par excellence teacher, technocrat, education administration and great human being. So at the onset I would like to request our HOD to welcome Professor Srivastava with the bouquet and Uttru. Soon, just 2 minutes. So before commencing the session, I would like to briefly introduce, though Professor Srivastava is well-known figure in the power engineering and he doesn't need any introduction, but it's a tradition, so I am going to start with a brief intro. So, thank you. Professor Srivastava graduated in electrical engineering from Institute of Technology, Banaras Hindu University, Varanasi. Ph.D. in electrical engineering from IIT Delhi. After that, sir joined IIT Kanpur as a faculty in the Department of Electrical Engineering. Before that, he served in the Institute of Engineers India Limited. So, sir is also but various administrative posts like head of the department at IIT Kanpur, Dean R&D and Deputy Director at IIT Kanpur. He is very active and well renowned in the field of research. He guided near about 31st Ph.D. thesis, more than 60 M.Techs and published more than 300 papers. Presently, sir is working as a director La Trobe IIT Kanpur Research University at IIT Kanpur. And he is the recipient of IEEE India Council Lifetime Achievement Award 2020. He is the member of Project Advisory Committee of DST SERV New Delhi since 2004. He is serving as Chairman of Expert Committee on Mission Innovation in Smart Grid formed by DST New Delhi since 2018. He is Fellow of IEEE, INAE, IE and IET. His research interests are power system dynamics and stability, smart grid, renewable integration, DC and AC microgrid, wide area monitoring and control, electricity market. So with this, I request Professor Srivastava to please come and start the session. Thank you, sir.
एक स्लाइडिंग स्विच है कंट्रोलर में स्लाइडिंग स्विच पॉइंट
Thank you, Arvind and Professor Das, for inviting me to NIT Agartala for this faculty development program. And in fact, it was overdue. I was invited several times, but then I decided that this time I must go. Unfortunately, because of some engagement, I could not come earlier. So thank you very much for that. I think it is a mix of student and faculty,
Yes, sir.
if I am not wrong.
Yes, sir.
Great. So that actually is required, because I mean the future generation also must know about the subject, and they are the future faculty most probably. So the topic which I have selected is on the distributed energy resource integrated smart distribution system, which includes storage also. And I will just try to go through few basics, challenges associated, and we have one Indo-US project which actually I was the lead for till I retired, and then our colleagues are looking after that, but I am still associated. We have some real-time field demo pilots which we are implementing, about to complete, so I'll discuss about that. So I think we are going through very exciting moment in power sector at least. After seeing a lot of problems in the past, now I think new energy has come, and I must actually compliment the efforts being made by the government, the electricity companies. I think they have very strong leadership these days. And now I would attribute some of the drivers which are causing this change, and they are very fundamental. I mean, like material technology development. Is it key to any kind of new technology development? So whether you talk about composite material, nano material, I hope you have heard about this. So they are finding place in electrical systems also, maybe insulating or the conducting material, and then the material like gallium nitride or silicon carbide have already found place in developing power electronic devices, new type of converter, and then ICT, the information technology and communication network, that has really changed the whole face of the power sector and many other sectors. I would say they are making it more smart. So concept of a smart grid, I think somebody talked last week. I think one of our colleagues talked in detail. And then on top of that, we have global environmental problems. Apart from local environment, we have a global environment where everybody is afraid now what will happen to humanity after a few years if this temperature goes on rising and climate change happens. We are seeing that. So that is also a major concern. And then everybody wants to compete now, starting from telecom sector, commodity market, now we have electricity market. So all these changes are coming up. So there is a long list. I am not going to read each one of them. But power electronic devices, sensors in the network, large number of sensors, ICT I discussed, and then electrical side, there is a lot of focus on distribution. That is where the talk is. So microgrids is a new concept which is coming up with a grid connected or off grid. And then automation everywhere, that is the key to the development, automation. And there are many platforms which have been developed, wide area monitoring system, synchrophasor based, then smart grid, everybody talks, advanced distribution management system, and then new type of rules are coming up, forming electricity market. Now I will little bit focus more on the environmental problem, because a lot of it is global concern. Everybody, all the countries are involved in this. In fact, there are two international bodies. One is called as United Nations Federation of Climate Change, UNFCCC. Have you heard of that? Other is IPCC, Intergovernmental Panel on Climate Change. And they frame guidelines, rules, they have regular meetings. So different agreements, the international agreements come. Okay, might have heard of Paris Agreement, and then Kyoto, and many agreements have come in the past, where everybody wants to reduce the carbon oxide or greenhouse gas emission. Now there is an agency called as IRENA, and they predicted that if you don't do anything, the temperature is going to rise by 1.5 degrees Celsius in 2050. I mean, 1.5 looks very small figure, but to climate it is very large. So many part of this, the ice will melt, the lot of areas will be under the sea, a lot of climate change will happen. So chaotic things happen. And then they say that carbon emission from different sectors they analyzed, and they actually told that power sector and heating sector utilizing electricity is the maximum contributor. So they will emit about 13 gigaton carbon emission, and that has to be reduced. So they have to reduce this much carbon dioxide. Now how do we reduce it? Why it is coming from this system? It is because of the fossil fuel based generation, okay, conventional generation, coal based power plant, gas based power plant, they are emitting carbon dioxide. So their share has to reduce, and renewables, that is why everybody talks about renewable in the form of solar or wind, that share has to increase. So they say that unfortunately the cost of these technologies are declining very fast. Now compared to, this is their figure, this is worldwide average figure, US dollar per kilowatt hour. If you see solar technology, I mean the cost has gone down by 85%. If you see concentrating solar, it is 68%. Wind, onshore 56%, offshore 48%. This is a comparison between 2022 and 2010. Okay, so there is a decline, and the figures here given is the levelized cost of energy, which decide the tariff. Okay, so this is the trend of levelized cost, and if you go for auction based market, the other color shows that. Okay, this is the price you will get. So good news is that it is going to compete the conventional generation, so one can go ahead with that, but there are problems, we will discuss that. So this is the figure they projected, that what will be the in terms of gigawatt and what in terms of energy generation in 2050 we should achieve. In 2030 the share should be 65%, and in 50 it should be more than 90% globally. India has projected to become net zero. This is moving, everybody is moving to a net zero. Even your campus wants to become net zero. I don't know whether it is already net zero. A lot of plants are there. I think it is negative pollution is there. So, 2070 India wants to become net zero, but 2050 if you globally you want to balance, this is the renewable energy share, you should go ahead. India actually, I am just giving some figure. This is my habit actually, this slide I use every time. So Indian power sector, you can get the data at Central AICTE Authority, monthly they publish. Unfortunately beyond December 22 they have not published. And another figure for renewables you get from Ministry of New and Renewable Energy. Okay, they have updated up to February. So you see here, still the share of coal based power plant is more than 50%, which is a concern. And then if you add your gas and diesel, then this is the 6% gas, and diesel is very less. So almost 60% we have the kind of generation which will cause carbon dioxide emission. Renewable share is growing day by day. In fact, government is very emphatic about adding renewables. Okay, we are leading the International Solar Alliance. We have, I think, India has office of that. Our Prime Minister launched that. So almost 30% we have touched in terms of the gigawatt capacity, right? Energy it may be less. So 30% of this, and if you see the breakup, the solar should have been 100 gigawatt by 22, but we have reached up slightly more than 60. That is fine, yeah. We are, because of COVID happened, many things happened. The prices went up, and China policy, and I don't know, many reasons are there. But we are hoping to add 450 gigawatt renewables by 2030. That is our target, huge target. I don't know how much we can achieve. So, but despite that we have shortage. Our total installed capacity is how much? Is about 413 or so is the present figure. But still we have 4% peak demand shortage. How much peak we are meeting? 215 gigawatt. 413 is this installed capacity, 215 is what we are able to meet. There is something wrong, is it not? So, and then energy, 0.6% shortage is there, not bad. Our per capita is lower, relatively lower compared to developed one, where it is up to 15,000, 25,000. But don't worry about that. We want to have efficient utilization, not consume the electricity in bulk. Okay, that is the best strategy. But losses are still very high. I think there is something wrong in figure published by CA, because this should be more than this. AT&C, this should be more than this. 20% AT&C losses is the 18.19, which includes the meter which have not been billed, whereas the T&D loss is 20%. So whatever it is, I think this is very high as compared to the global figure. But we have very strong transmission network. Fortunately, we are one of the best transmission network we have. There are 5 regions in which our electricity is operating. Regional electricity companies are there. Okay, northern, southern, eastern, northeastern, and western. Right? Now we have a single grid. We have a single grid. 30th December 2018. Everything is synchronized. Not 18, I think 13. In fact, how many of you remember there was a blackout in 2012? Remember that? 30th and 31st July. 31st July, your northeast was also under blackout. 30th, it was only north. I was one of the 3-member committee investigated this blackout. The reason for that. Anyhow, that is a separate topic, 1 hour topic. Okay. So that time southern was not synchronized. All others were synchronized. Right? And there were many reasons. Don't worry about that. But we have a very strong network. Inter-regional we have connected through DC as well as AC link. And we have gone up to 765. There is already a test line of 1200 kV AC, and DC is plus minus 800 kV. So this is the voltage we have. 5 apart from large network of 500 kV DC. Okay. So this is the figure of. So our 220 kV and above is this much kilometer, 11,48,000 circuit kilometer as of November 22. And inter-regional transfer is 112 gigawatt. Okay. But you see the trend in adding the renewables. Southern region has almost reached to 40% share, followed by your western and northern. Western you see 133 and 37, so almost 30, more than 30%, and northern is close to 30%. It is still less in eastern, northeastern and island regions. Okay. So this is the renewables here. Now adding renewable is good, but renewables has several problems. We'll discuss how to balance that. Fortunately, we have single grid. So if one part you have more renewable, other part you don't have, or renewable power goes off, power can flow from one to the other and it can balance. Okay, that is the advantage of single grid. We have single frequency 50 Hz. Okay, so these are the challenges. Renewable you can add, but you should add the transmission network accordingly to evacuate the power. And they are very variable. So power may flow from one place to the other in the morning, but it may reverse in the afternoon. Okay, looking at how much solar we are generating or how much wind we are generating. Solar will be very high during daytime, but it will be zero during night time. Wind will be higher in night time. Okay, so southern region has more wind power plant, and then output is variable. So that variability causes stability problem, power quality problem. That is what we are discussing. Voltage and frequency control becomes difficult because they don't have inherent reactive power like solar. They don't have inherent reactive power support like synchronous generator in conventional. But there is a way to generate reactive power at the cost of real power. Okay, reducing real power, your smart inverters can generate reactive power. Okay. So power quality, I think you have discussed enough. Harmonics, flicker. I will talk about continuity of supply is also kind of power quality indicator. Okay. It requires very accurate forecasting, minute to minute forecasting. So India has already installed several renewable energy management centers. It is part of the control centers, like 5 regional control centers. 3 of them are already having. Few states have that. So it is already there, but they want to install everywhere. Then advanced distribution, because these renewables will come on the distribution side also. So the perfect utilization of renewable is required. So you need some kind of automation, some kind of advanced distribution management system at the distribution. Okay. And if you are forming microgrid, then microgrid energy management system is required. Protection becomes tricky here. Like in distribution, it was one directional flow, but now the direction of flow will change. So you have done relay setting based on considering one directional of flow, but if changes, all protection will fail. Okay, the one which is not intended to operate will operate. Okay, so you have to design adaptive protection or directional protection. There are many standards which have been suggested for integration of renewables. Now let us focus a little bit on distribution side. In the past, it has faced several problems. I think most of you are aware. Our losses are high, no data was available to monitor the health of equipment. Still, data is not there. Sufficient data is not there. Quality was poor, metering billing was missing earlier, and then ICT infrastructure was very minimal, and customer was neglected. I mean, this was one sector where if your bill is faulty, you have to worry about that. You have to run around the electricity company for 10 times and get it corrected. Whereas you are paying, which should not happen. Actually, they should be after you to correct the bill. Okay. So customer focus was missing. They had no participation in energy management. And supply interruption, you might be knowing several hours of interruption was there. It was unidirectional flow, as I told, and it was a passive network. Passive in a sense, it was not participating in the power management. Okay, but Government of India brought several reforms. Now, they started with APDRP, which was Accelerated Power Development and Reforms Program, and they selected certain circles, and transmission distribution network were strengthened in that, modernized, and few actually automation features were added. Then they revised APDRP, okay, in which actually they also introduced IT enablement, okay, the SCADA system, IT enablement came. Finally, a few years back, they are calling it as integrated power development scheme, okay, in which metering is 100% metering is the focus, strengthening of network and the distribution network embedded with IT back. Because unless you have nervous system, your brain cannot function. So IT is required for your control center to function. So you have an analogy in human being. So the blood flow is like your electricity flow, and nervous system is acting like your communication network. Brain is like your control center, which is making decisions. These are sensors, hand, eyes, and ear. They are sensors. Okay. So like meters you have, or thermocouples you have, they are sensors. Then many other schemes came in rural sector because this irrigation feeder, they were combined with the residential and creating a lot of problems. So they separated that through a scheme known as Deen Dayal Upadhyaya Gram Jyoti Yojana, and then they said meter should be there at everywhere. Now new thing is that they also talked about microgrid with renewables, and which may be either off grid or the grid connected for accelerating rural electrification. To help the electricity distribution company, because they were in red financially, so they brought few schemes. One is the Ujjwal Discom Yojana. They gave financial support, but not much effect was there. So they said no, it should be now performance based. So new scheme, revamped distribution sector reforms, is launched in 21. Unless you perform, you will not get the next installment. Okay, you have to give proper scheme. So they are doing a lot in AICTE, but that has caused really the large deployment of rooftop and ground mounted renewable sources. In fact, government wants about 60% to be ground mounted and 40% rooftop. So just imagine if you want to add 300, 350 gigawatt, how much will be the rooftop and how much will be the ground mounted. So rooftop also have to be accelerated. And rooftop will definitely come at the consumer end, residential buildings, wherever roof is available, and it will affect your distribution network. But it is also with the ICT network, it is going to make it smarter. Okay. So advanced metering ICT infrastructure growing actually slow, but at a slow rate, but it is growing. Microgrids, few microgrids have already been formed. I will give example of what we have implemented. Along with energy storage. Why energy storage is required? Because these sources are having variable output. Now you have to do power balancing. Conventional generator traditionally has a very slow ramp rate. So they cannot meet the minute to minute changes. So storage is required with converter interface, which can act very fast. Bidirectional type of converters you use. It can be used for charging as well as discharging. So energy storage is also required, but this is one of the weakest link in the whole game of adding renewables. Okay. Then our life is a little complicated. We want to still reduce carbon footprint in transport sector. So EV program is there. But that is also affecting your distribution network. Imagine all the cars are being charged at the same time. How much load will come? I don't know how many gigawatts will come. Okay. So that is challenge to the distribution company. And then I talked about different reforms. As a result, it will become active because there will be some generating local generators who will participate in supplying electricity back to the electricity company or trading with other consumer. We call it as peer-to-peer trading. Okay. And flow become bidirectional. And network is becoming active. So that is how future active distribution network will look like. So you will have your wind farm or solar at the tail end, and bidirectional power flow will be there. A lot of intelligent devices will be put along with reactive power compensator to improve the voltage and frequency of the system. And it may or may not be connected to the main grid. Okay. But it requires all kind of the decision making tools being part of your advanced distribution management system. So that is very much important. Now little bit on electrical storage. This is only one slide I am showing. There are 4 major types of storage. One is mechanical, electrical, chemical and electrochemical. Mechanical storage is pumped hydro. We already have pumped hydro plants, and government is now having very ambitious plan of adding pumped hydro, because this is one viable option at the grid level, main grid level. If you talk about megawatt, gigawatt of capacity. Compressed air, unfortunately India has not explored, but Europe and Canada I saw, they have a long drive. So what they have a tank inside the earth. I mean there is a buried tank, and they compress the air, store it, and whenever during off-peak hours, but during peak hours they generate. The compressed air is used to run the turbine and they generate electricity. So this is also a viable option. I talked to one ministry person, I tell, why don't you promote this? They said, we need lot of space. I said, why don't you go to the underground mines, which after mining is done, it is very dangerous to retain that. Put the vessels there, so it will be safer also. So at least those places you can put. So I said, sir, we'll explore. I don't know, they have not explored it. Then flywheel actually could not, for larger sizes could not be developed, but there are applications. Electrical storage, superconducting again is a research stage, not a very viable stage. Supercapacitor, yeah, it is there, but rating is smaller, not very large rating. But supercapacitor, one good thing is that it can respond very fast. So for any transient disturbance, supercapacitor can come. But long time energy need cannot be met by the supercapacitor. So it may be combination of supercapacitor and battery. Which one can go? Okay, because battery is very good for the long term energy support. Okay. Fuel cell, there is a very again government drive on hydrogen based energy generation, and fuel cell development will take place because they want to have green hydrogen. How hydrogen can become green? It doesn't have any color, is it not? So, but green energy technology you use to generate hydrogen. Okay, these are buzzwords. Green house gas, green hydrogen. Okay, green revolution. Many things are coming. So that is why it is a little green. Okay. And then electrochemical, I think this is, lead acid is a very mature technology. Advanced version is also there. Lithium ion also is already developed, and what in our projects we are using is lithium ferrophosphate technology, which is safer. But these two are still at the development stage, and they offer a better potential than lithium ion. So we have to see in coming years. Flow battery is good for grid level, but wherever it has been installed, it gave some problem. Okay, we are also thinking of in our pilot, but we did not install. Getting feedback from our US counterpart, they said no, it is giving problem, so we have not done. But that also has potential. Okay. Now, microgrid. How many of you are familiar with microgrid? What is a microgrid? I mean, in a small area, if you have generation, if you have loads, if you have for balancing purpose storage interconnected with each other, may be connected to the grid or may not be connected to the grid, that forms microgrid. Okay. It is a independent electricity system of smaller size, micro size, okay, which can operate independently, can be controlled independently. That is, there is a very nice article, actually it is a white paper. I don't, if you are IEEE member, you can always download it. I think I am leaving this, so you can download it, must read about microgrid, all aspects of microgrid. Now, types of microgrid, it can be off-grid, it can be grid connected, or it can be networked microgrid. Two microgrids, maybe two villages form microgrid, and they are interconnected. So I will give you the example, which we have implemented, interconnected microgrid. Okay. Then it can be AC, it can be DC, it can be hybrid. Either the coupling, point of coupling is a AC voltage or DC voltage, or there is a DC generation and connected to the AC system. So DC actually offers potential. I think you have, there are some advantage over AC. You need not worry about the reactive part, but there are problems also. The production becomes very tricky because there is no natural current zero. Okay, so you have to design a special production. And then based on power level, people call nanogrid. Few kilowatt house can have this battery and solar, and that is a nanogrid. Or microgrid up to 10 megawatt. Normally few kilowatt to 10 megawatt is a microgrid level. And then bigger one is called mini grid, and then your bigger grid. Okay. And what opportunities it offers? Like you can use it for peak shaving because you are using renewables, which can be utilized for peak shaving. Voltage control, you can add in your inverter special feature for voltage control. Islanding operation and black start. And grid resiliency, this resiliency is also concerned. So energy during extended outage you can get from the grid. In fact, 2012 when we investigated, we found that on 30th July restoration of electricity took 14 hours. On the next day, 31st, because they had learned little bit, it took 8 hours. One main reason was that no pocket was having electricity to black start the generators. So if you have microgrids, few pockets will always be there. I think there were very few pockets which were having electricity. So they could, with a lot of difficulty, they could. Whereas if you have microgrids, let us say at community level or strategic locations, you can take the electricity and restart the grid. Okay, so it offers a very great advantage there. Don't worry about business model, different business models are there to operate it. But technical challenges you have to address. Voltage stabilization, power management. If you have several sources, you have to optimally manage it. Power quality. More power electronics, power quality problem increases. It's like your medicine and disease. So new medicines are invented to take care of a disease, but as a result, new disease come. Okay, and this chain continues. COVID we have overcome, then something else came. Your immunity has gone down, so it will come. So power electron is good for controllability, fast operation, but harmonic problem, everything is there. But fortunately, solution also comes from power electronic circuits. Okay, so that you have to take care, properly design the circuit. Then protection, I said, because of bidirectional power flow becomes challenging. Stability, most of the sources are not having inertia. Solar doesn't have inertia. So if you add out of, let us say, in 2030, our installed capacity is 800 and 800 gigawatt, and 300 gigawatt is not having inertia. That is a great challenge to maintaining stability, because inertia may make your system slow, but it is good to stabilize this under disturbances. Okay, so lot of new concepts have come. The virtual synchronous generator concept, or modifying the control of the converters to add artificial inertia. After all, inertia, what it does, under oscillations, it will generate counter power so that this oscillation reduces. Is it not? So you can generate through electronic circuit also. Okay, so that is possible. Then grid integration and islanded operation once you have these. Now to achieve these three levels of controls are exercised, at least in distribution side. One is at converter level, primary control, where we have voltage and current control loop. I think many people might have talked. We employing group control or MPPT control, harmonic unbalancing controls. This is at converter level. But if you have converter interface to a renewable and then you have storage, several renewables are there forming microgrid, you need microgrid energy management system. That is called secondary level control. So optimal power sharing, balancing, storage charge discharge control, because storage also, the state of charge has to be maintained between, let us say, 20% to 80% or 20 to 90% maximum. So it should not go below that, otherwise your life will be shorter, and it should not exceed 90%. Okay. So optimal charge discharge control, and then islanding detection management, voltage stability control within the microgrid. Then if you have microgrid and rest of the distribution network, then optimally you have to operate all of them together. That requires kind of energy management system, distribution management system, or advanced distribution management system, and that is tertiary control. Okay. So forecasting, very accurate forecasting is required, renewable forecasting, load forecasting, power management, volt-var control, reconfiguration, fault detection, location. Then market will also evolve, local markets will evolve. So you should have market-based control. Okay. These are some of the standards. I am just giving the list, you can refer whenever you want. But if you talk about a smart distribution system, what are the key components required? One is your SCADA system. To automate the system, you need a SCADA system with proper communication backbone. Okay. Second is GIS. GIS is very helpful actually, and it actually integrates all the hardware, software and data for analyzing the system, displaying in the user interface form. Enterprise resource planning software is required for various applications, billing application, document management, customer information system, and so on. Customer information system is important to address the problems of the customers. Okay. Automated system is required, and also provide the billing information. Outage management system to identify, diagnose and locate the fault. It is part of your trouble call management. advanced metering infrastructure required because a lot of smart meters are being put. How to optimally utilize their data. Communication, I said, it should be two-way communication. Then advanced distribution management system, and there is a new terminology being taught, distribution system operator. Like, is there any operator at transmission side? System operator? Anyone? Is there any system operator on transmission side? Have you heard the name of POSOCO? Power Grid is a transmission company, but a new company was formed which was called as POSOCO.
CCI, it's a name changed.
Now recently it has become Grid Controller of India, GridCo. Okay. So if you are a power engineer, you must know that. We have central transmission utility known as Power Grid. And the transmission and generation network is being monitored and actually operated by system operator, single system operator, which manages all your 5 regional control center and national load dispatch center in Delhi. And that was known as POSOCO. 2012 it was formed. And then it is now renamed as Grid Controller of India, GridCo. Have you heard name of Suni? SK Suni? Many of you heard. He posts a lot of email. So he was the founding chairman of POSOCO, my good friend. Yeah. So, and now the new one has come. Yeah, he has retired. So, like this transmission side, transmission system operator, there will be distribution, but several numbers. Okay. Every state may have one or several of them. And then supporting decision making tools, data analytics are required. Please stop me if you have any doubt. Huh? And if I find somebody sleeping, I will ask you to get up. Okay. So, DSO little bit because this is a new concept which came from our project actually. We have written a white paper likely to be launched by Ministry of Power and Ministry of Science and Technology. Okay. We are just waiting for the response. So, when you install renewables, the system can be in 3 stages. One, without renewable, passive, which was the past, or semi-active, which is currently we are having semi-active. Some renewables are there, but that also has to be managed properly. Then fully active distribution network, when you have large number of DERs, we are looking for 2030, that is stage. Then DISCOMs should have proper automation and dedicated distribution system operator, okay, to manage these renewables. So the difference between conventional distribution management system and DSO will be mainly responsible for system operation, not for network management. So they will actually manage optimally the distributed generations and the storage. That is the key idea. They will also allow local market to take place. They will be facilitated on that. So there is some definitions I think in that line given by one Australian company. Now there are few countries who have taken lead like Australia, UK, Ukraine. Ukraine is a busy somewhere else, but they also have introduced the DSO concept. USA and European Union. Okay. So they also have identified and also implemented some DSO. So the learning we got from after reading all the literature, our committee was there, I was also part of that we have to investigate some viable option for India, not copy any model. Okay. Because our situation is different. Distribution is a kind of tailor-made network, not a standard network. Okay. Then it should be such that it should provide flexibility in the grid. Then it should be performance, we will bring performance followed by private investment. And the technical standard has to be developed, government has to support. So we wrote a white paper as part of our Indo-US project, and as I said, it is going to be launched soon. But these are the operation which DSO will perform at control center. Network operation, system coordination, resource adequacy is a new word. Whether your resources are adequate to take care of variability or not. So whether you have enough reserve kept, that also is a major for resource adequacy. Network planning has to be integrated with distribution planning, generation planning, forecasting, scheduling dispatch, metering, billing, detection of theft, particularly in India, network security, market, and ancillary services, once you talk about market. But it will offer a lot of advantages, including facilitating large number of RE integration, okay, apart from your electrical advantages listed here. Okay. Now coming to our project. So you got some idea about the challenges which we are going to face, what entities will come, and if you have any question until this point, please let me know. Any question until this point?
Sir,
Yes.
question. Sir, can we use gravity energy storage system in India?
Yeah, but the amount is, people are talking about gravity energy storage, but the amount of power you can generate as of now is not very cost competitive. So, yeah, but this is being explored.
Sir, is there any plan made by Indian government related to it?
Not yet, but because it is exploratory stage. Government will come into picture when it is proven. So bodies like DST or SERB will come to support the concept, fund it at level after scrutiny by the expert. But if you have bright idea, you sit right to DST or SERB, get funding, prove it, and then reach government that they should accept it. Yeah.
Sir, if we use electric vehicle as energy storage in India, then what challenges we can face?
As what?
Electric vehicle as energy storage in
Yeah,
India.
I mean, this is V2G operation, vehicle to grid operation. So you must know that none of the vehicles which are operating in India has V2G capability. Okay, converter has to be properly designed. Your communication also has to be designed to the grid. So it should be, vehicles should be V2G. There are few vehicles, Tesla is there, and also Nissan, one particular model, which has V2G capability, but no other one. We were trying as part of this project to approach Tata and Mahindra, but they didn't agree to modify their model, okay. But it should have V2G. Yes, it has potential because at night time you can charge, and whenever peak load is there and your vehicle is parked somewhere, like if you go to office, your vehicle is parked, not being used. So this battery can be plugged to the grid and you can supply it, but market should be established, local market, to give you revenue, is it not for that? And your vehicle should have V2G. But answer is yes. Yeah. Thank you. Yeah. So coming to our project, actually,
What about the geothermal?
geothermal actually came because it is site specific. Geothermal is a site specific, and geothermal was explored. I think in Ladakh region we have geothermal, or somewhere in northern part. I don't know about northeastern, but there are few countries where geothermal is there. Yeah, very much there. But again, overall contribution compared to the grid side is less. Geothermal is less. Yeah, but if you have site, you use it. There is nothing wrong. Yeah, but you have to work out the investment in that. And then if it is very remote site, then you have to connect to the grid. Yeah, but it is proven technology. Geothermal, ocean based storage. So all these are there. So yes. Now this is a consortium of 31 partners. 16 from do we have time? 16 from India and 15 from 16 from US and 15 from India. Okay. And IIT Kanpur is leading from India side, along with 4 other IITs, Bombay, Roorkee, and Delhi, and Bhubaneswar, and TERI, Netra from NTPC. There are many other utilities like BSES, Rajdhani in Delhi, or UP Power Corporation. We have the Dakshinanchal Vidyut Vitran Nigam, which is looking after the rural distribution in Kanpur, and then Power Grid is also supporting, and we have several industries. Similarly, on US side, Washington State University is leading, and West Virginia, MIT, Texas A&M, Hawaii National Natural Energy Institute. They are the academic partners. Apart from their government labs, like Berkeley Lab, NREL, then PVNL, PVNL is there. So, and then many utilities and industries are there. So it is a big project, $30 million project, and we got in 2017. It is likely to be completed this year end. So aim was that we should evolve future smart and resilient distribution system. Not only do research on almost every aspect of the future distribution network, but also demonstrate in the field. Okay. First test at the lab level and then demonstrate at the field. So, and overall aim was that optimal utilization management of DRs, interfacing DR and microgrid control system with storage, and also demonstrate DSO function. Now, we actually divided the overall work into this 11 thematic area. Actually, theme 3, which is our energy storage, microgrid and active distribution system research, cyber security, where cyber infrastructure and cyber security aspect have been addressed. Then your ADMS functions and DSO functions, the regulatory aspect and market aspect. So these were the key research areas we divided, and we formed the teams from different organizations, both from US and India, and we worked on that. And then, we also had the lab pilots at 6 places in India, all 5 IITs and TERI, to test whatever R&D concept is there before adopting into the field. And then field demo, 5 in India and 5 in US, under rural, semi-urban and urban setting. Okay. And then when you go to the field implementation, social impact analysis has to be carried out. And again, few benchmark, I think some benchmark will become IEEE benchmark, which we have developed. We are talking to IEEE, at least rural feeder and then semi-urban feeder. So I think in principle they have agreed, IEEE committee, and then like your IEEE 13 bus system with renewables, you may get UI assist system sometime later. Okay. So this was the project. I just example of like storage theme. What aspects we have addressed. So storage, one thing is important, where to site the storage. Like in your campus, if I want to put the storage and you have solar everywhere, where is the optimal location? How many storage I should have? What should be the size? So that kind of exercise. Then modeling the storage for analysis purpose. Some partner wanted to develop prototype of storage also. Then various schemes of charge discharge, optimal power management, health monitoring, that have been developed. Now coming to your ADMS, DMS, DSO functions, many aspects have been like sensors and data analytics, solar wind forecasting, PV monitoring, load profiling, system reconfiguration, state estimation, optimal operation, volt-to-hour control, demand side management, reliability, and TSO. So our interaction, so transmission system operator, distribution system operator will interact at some time, because power generated in distribution will also flow to transmission and vice versa. Okay. So this is some representative example. Now this is our lab, which partly was there with other supports. I think Arvind has seen some part of that. So we have very strong real-time simulator lab, RTDS, Opel RT, and then Typhoon, all 3 types are there. And then this is power amplifier we purchased as part of this packet. And we also created a reconfigurable test bed, where any kind of microgrid you can physically implement. So power electronics components, our power electronics group developed. You can develop any kind of load with a scaled down model, and generators, PV as well as that, emulators are there. So this test bed can be used. It is not open, but we are most welcome to use it. Okay, free of cost. And then I will focus more on field demonstration, because the India side we had 5 sets of field implementations. 3 are being coordinated by IIT Kanpur. One is rural, in actual village of Kanpur. Other is semi-urban, because semi-urban, what is semi-urban? How does semi-urban differ from urban? Is Agartala a semi-urban or urban area? Urban area. Okay. But if you are passed through, there will be pocket of towns that is semi-urban. The difference is that in urbans you may have high-rise building, many urban cities, but semi-urban you will have mostly single or double story buildings, and may not have all the facilities in semi-urban like urban areas, like big hospital and others. So we said our campus is also semi-urban. Okay. My house was single story, that lane was single story, because actual semi-urban was too big to get funding from the project. And then urban is having tall buildings, or it may have institutional building, commercial buildings and so on. So that is urban. And that also we have implemented inside our campus, because we have 7-story housing also, and there are residential institutional areas. But the NIT actually wanted to have rural pilot, but they shifted to their own campus, calling it a semi-urban. And urban, there are 3 pilots by TERI. Okay. So this, and then we have also developed from scratch an indigenous advanced distribution management system platform. We already, our campus was under SCADA, so we extended it, and ADMS we are implementing. Now these are some of the details. I will go one by one later on. So the rural one is in actual village, but it is in partnership with the local power utility and one NGO actually, because they actually had lot of approach to villagers. Then semi-urban is single housing stories. So 2 lanes we covered, and we have gone for 5 kilowatt of solar SPV installation in about 30 houses where site was available, because not everywhere you can put. There may be shadow or something. Then urban, we took one residential, two residential multi-story faculty housing, and one actually academic building. That was a center for environment. Okay. And then DSO ADMS was implemented, and we have a control center for that. Right. Now coming to the details, I just little bit about the rural electrification. Now 2018 December, under a scheme, Saubhagya or something, the Government of India declared it is 100% electrified. Okay. But when we did survey, many places, although a village has maybe cluster of villages, a big village has cluster of villages. So let us say village is Harnu village, that is what we got. But it has 4 clusters, one having 75 houses, other having 85 houses, one has 300 houses, other one has 25 houses. They are about less than a kilometer away, but overall it is a single Gram Panchayat. 2 were electrified, but 2 were not electrified. Okay. So there are many hamlets which are not electrified. That is a big problem. Household electrification is quite less in India. Okay, maybe 60-70%. So although the wire has gone, transformer has been there, about 20% of the houses are electrified, but not all of them are electrified. Okay. Reliability is poor, and then they have also brought out microgrid policy, by the way. Many states have also adopted microgrid policy. But many private players, NGOs, they are already setting up some solar and plants. Smaller size, maybe to feed your lighting load and also the charging station. Okay. But you may be surprised, the tariff they charge is about 100 rupees per kilowatt hour. They don't mind because they consume very less electricity, and for them it is 20 rupees only, but tariff you calculate is very high. We visited some of them. Okay. So what was our approach? First of all, we took the help of our NGO to identify the village. We found that 2 hamlets of one village are not electrified. I said, well, this is a good case for us. And then how do we know that how much electricity they will consume? They have not seen electricity. So we did social survey. our social scientists, students, they did social survey with lot of resistance. They answered some question, and then we also took the load pattern in those villages which are electrified, and then we came out with their load projection requirement. Accordingly, we selected the solar PV because it is site for solar PV. One of the village has lot of cattle, and the cow dung were all scattered, very dirty lanes. They don't know how to utilize it. So we thought we will put biomass, cow dung, utilizing cow dung, and also they were cutting the wood for burning purpose. So we said that also can, wood waste also can be utilized. So it is a hybrid type of biomass. So based on our requirement, in one of the hamlet where cow dungs were not available, 70 kilowatt solar, in other one 30 kilowatt solar and 30 kilowatt the biomass we have got. And both of them we have provided adequate energy storage. Then there is a long calculation involved. So we worked out about 100 kilowatt hour in each we can have. Then we did a lot of R&D and we came out with a specification, selected the vendor. Now question comes, well, this project is 5 years. After that, who is going to manage? AICTE board said that they will not take over, they are not generation company. I mean, my goodness. Although they are partner, they are not able to take it over. Then we came out with the idea, local society we have formed, where 5 executive members are from Panchayat, including Pradhan, 2 are from IIT Kanpur, 1 from the NGO. And we said that they will be responsible for managing the system, okay, collecting the bill from everywhere, and AICTE board will provide us net metering. At net metering, one single connection through their transformers. So transformer they provided and wires also they provided. So that is the arrangement management model we have put. Okay. So sustainability in they also, while doing survey, they said that more than AICTE we need water. Our crops are suffering. We don't have irrigation. Here, only one fellow has charges very high in the whole village. All four. Then we actually approached our committee and got sanction of 6 solar-based water pumps, independently operating, and 2 hamlets are provided with 3 solar pumps, which is operating already. And that has given a good result to them so far as agricultural product is there.
Sir, I have seen a video.
Sure, please go ahead. Thank you.
I will meet
Yeah, I'll just 10-15 minutes. So this is the scenario, initial dialogue we had. If you see here, how much effort we have made. This is one of the picture I am showing in a village having lot of cattle. You see all are scattered. You see any wire here? No. And only few had few watt of solar. That's all, 1 or 2 houses. So this is the very situation of the village there. Then we had a series of meeting with them. Probably I am sitting here and wanted to convince them that this is our plan, what is your view. And then AICTE company actually installed transformer as part of their contribution and laid the wire to their houses. So right now they have their meter, but we'll switch over to our smart meter once it is commissioned. And this is the groundbreaking ceremony. You see myself breaking the ground, and then having dialogue with Gram Panchayat to approve the bylaws. Very difficult task. It's not very easy task to convince them. So several meetings were held. We offered lunch at IIT Kanpur. They were happy and they signed. So that is the scenario, and finally these are the figures which I already talked. Almost 700 people will be getting benefited out of this. And then we also face a lot of difficulty in getting the land actually. Land record is so poor. There is a road going on and there is a panchayat land, and they said that this is reserved for the road. I said, what about this road? Will you create another road there? They're nothing doing. It is in our record. So we cannot allot this land. So we approached the DM, we approached the ministry there, and then it got approved. On exchange basis, some other land was made as land for road. Anyway, how things happen in India. And this was made free. Okay. So anyhow, we got approval, so a lot of difficulties were there. Now this is all interconnected microgrid. The two hamlets, one having only solar of 70 kilowatt and then your grid connection, battery energy storage, feeding to the village. We also put a street light. None of the villages have a street light. So we have given a street light to those villages also. And then biomass in the other one, but it is interconnected together. They are 700 meter apart. Now the two are AC grid. And can you synchronize them directly? No. They may have different voltage, different frequency. So what we found to put a converter, AC, DC, AC converter, okay, to synchronize them. So this was also new to the converter company, and they also designed, and now it is in operation. So it is kind of interconnected microgrid. So in case of surplus power in one village, it can flow to the other, and vice versa. Aim is to minimize the power from grid. So this is the buildings we created, control rooms, and then later on meeting, this is the biomass site. In fact, in Chabba, Nevada, there are two buildings. One is this control room, other one is actually we want to have local employment generation. So we are approaching NGO to set up some agro-based the industries for packaging purpose and cleaning purpose, so that they also, their livelihood increases. So that is already there actually. So this has many aspects. I'll skip that, because before setting up we did lot of simulations. We designed the converter, and this is the rural main distribution system. We simulated both in real time and on MATLAB, and then we designed the controls which are already implemented in the site, like DC voltage control, which DC regulator gives active current reference, and then current regulator gives the command to the inverter voltage reference point. Under voltage and over voltage protection was also filled. So, and then we did sanity check. If grid is not there, then PV is the only source. So if PV is there, then current is flowing, otherwise it is zero. So that check was there, and then if it is grid connected, nothing happens actually to the voltage there. Okay. So after verifying everything, then we have gone ahead. Then semi-urban, actually that single story housing, we have put solar, and then these are the meters and the inverters along with solar. About 30 of them we have put, but we have also gone for EV charging, by the way. Somebody asked about EV charging, and we also have a one vehicle, electric vehicle, for testing purpose. Okay, but V2G we could not get with, even despite lot. So that is operational. This is the battery and inverter which is outside. This two lanes we have covered. These are the two lanes of our campus, which has an isolator at the end. So it doesn't form ring, but in case of failure of one side supply, it can feed the whole. Two lanes can be fit from one. So we have decided to put the battery at the substation end for better controllability. So although it was when we did optimal sizing siting, it was the second priority, but we preferred because of the connectivity, better connectivity and control. Okay. So storage have been put, and then here actually, I mean, you may not be appreciating, but even relay study we did, that if there is a bidirectional flow, what kind of relay we have to put, where we have to change the relay, and so that also has been designed. Okay. And then everything is controlled by microgrid controller. Okay, in the campus. Urban, this is the housing complex where solar have been put, but it is smaller size because of the availability of fund, 25 kilowatt, and load is 75 kilowatt. And then battery of 50 kilowatt, roughly 50 kilowatt, 100 kilowatt hour has been put. So 50 kilowatt hour has been put. These are two housing complex we have covered. Idea is that if solar and battery is there, they can take the load completely. But if power is not there. But night time, if only storage is there, Then only emergency load we are meeting, like lighting load, area lighting load and lift load, which otherwise is being fed from a diesel generator. So diesel generator we want to avoid. So that is the application. Now one very interesting thing, do we have time?
Yes, sir.
See, thermal energy storage. I don't know whether you have heard about this or not. This is very good for city area or the tall buildings where air conditioning load is very high. In fact, there is a survey done. Almost 44% of the load is air conditioning load. So this is going to create a lot of problem, and this is increasing day by day. So how to reduce the peak demand which comes in the daytime because of air conditioning load, large air conditioning load. So this is another viable option. It is not electrically connected, but it is thermally connected. Okay. So what it contains, I'll just show you here, is a tank which is filled with glycol solution, and this building already had a air conditioning system, 75 ton chiller system, and total peak load requirement is 150 ton. So during night time when load is less, the power from the chilled water supply from the central air conditioning will be taken inside the tank, and it has a phase change material already inserted into that. The property of phase change material is that even at low temperature, sub-zero temperature, it remains liquid. Okay. So the glycol solution with phase change material remains liquid even at -6 degree or -10 degree. So we are cooling it to -6 degree during night time. And daytime, this whole solution supports the chiller operation of the building. Okay. There was one with underground tank already there, 230 ton hour. That also we renovated, and this is 525 ton hour. So total capacity is 775 ton hour. Okay. Peak load is 150. So if peak load is there for 5 hours, it can support. But peak will not happen always, so it will be distributed average maybe 75. So 10 hours it can support in extreme summer. Now we have seen that after charging one charge, it supports for several days during a modest temperature days. So this is operational since 20, giving very good results. And all its operations are monitored at our control center. This is the display at control center. Complete process diagram, the meter, the sensor status and so on is being monitored. And it has resulted into, this is the comparison between 19 and 21, because 20 was the COVID period, everything was closed, so load was 0. So 19 and 21 summer, except 1 month, you see the reduction in the load, energy consumption, because of addition of this particular one. Okay. And it's not very costly, so one can try in the larger buildings, air conditioning load support. Now we also are implementing ADMS in a already existing infrastructure. This is the control room we built with another project with training center, and this is the display panel. So whole campus is under SCADA, all 11 substations, one main substation is under SCADA. But in the new project we have added these microgrids that need to be monitored, renewable has to be optimally operated, forecasting has to be done. So ADMS tool need to be developed. There is only one indigenous vendor for SCADA, that is Synergy. So we took them as partner and we are developing indigenously. So this is the SCADA layer. So on that we have added ADMS layer. This is the SCADA layer. And metering infrastructure we have also integrated. There are many new features, like it utilizes common information model, which is very new to the SCADA system. Okay. And it is a plug and play type, any thing you can add later. These are the functions we are already putting into that. 3 of them are already tested, many of them are under testing. Okay, it will have GIS, outage management, meter data management, weather forecast. It can be used for training purposes also. Now, very quickly, other pilots I will just go very briefly, like TERI. TERI, you know, the Energy Research Institute in Delhi, which was Tata Energy Research Institute earlier. So they are collaborating with their local distribution company BRPL, BSS Rajdhani Power Limited, Reliance Group. So they have demonstrating the use of storage for 3 different applications. One is to reduce the overloading of transformer. They don't want to replace the transformer. Transformer was getting frequently overloaded. So they said that after 80% of loading, they will switch on the storage support so that it never gets overloaded and its life increases. That is the overall objective. And then they can use for peak load management, energy arbitrage. Another is in a society, housing society, where they are using diesel generators for backup. So that they want to reduce and they want to use the storage. Third one is their own institutional area. They have solar, but it is not dispatchable because no storage was there. They want to make it dispatchable and also test for energy time shift. How to peak load they can shift. Okay. So they did a lot of extensive simulation and came out with certain ratings, and then vendor standard ratings they selected 288 kilowatt hour for first application, 216 and 72 for the other 2 applications. These are the benefits they anticipate: transformer investment deferral, peak power purchase, reliability improvement, life increase in transformer. In the reliability, diesel consumption saving, electricity bill saving and emission curtailment in the society. Power purchase cost they want to reduce in their own building and better utilization of solar. They also did some simulation. Actually, this utility, this is the example of the transformer overload management. So this is the transformer 990 kVA, and the utility also has their own solar, by the way. But there is a cap put by regulatory commission how much they can go, and they are connecting the battery through certain control scheme which were designed. This is a single line diagram. So they developed control logic. They also worked out the optimal size of the storage. You can read it leisurely, but I'll just give you the basics here. It has actually 2 major parts. One is the future solar forecasting, year by year, looking at the historical data, regulatory restrictions. Other is the load forecasting, and then they say what should be the cutoff for overloading, 80%, 85%, optimally they want to calculate. Finally, they established that beyond 80%, the storage should come into picture. And they worked out 240 kilowatt hour was the requirement which was worked out. And looking at the standard size, they have gone for 288 kilowatt hour. So storage sizing is also tricky. It's not that easy. And then they saw the impact on life of transformer. If you don't put this is the loss of life to 50 days per year. Which gets reduced to about 50 once you put the storage. Okay. And this is the actual picture. So this is the connection diagram with control center they have put, and this is the storage site, and this is the logic they have put. Now Netra one is delayed. Actually, this will come. Still not work has started, but they want to put 4 megawatt ground mounted solar. They already have the municipal solid waste generator 500 kilowatt in their campus. They have diesel generators. So diesel generator consumption they want to reduce. Grid they want to consume as less as possible, and ultimately they want to switch over to independent supply. Okay, that is the aim. So they have gone for 1 megawatt hour battery, 1 megawatt power rating, 1 megawatt hour energy rating. Okay, this is the last slide. And they are developing the controllers to maximize renewable generation with minimum grid support. They are prioritizing the loads. And then one more thing I think is not listed here, they are going for the induction heating in their cafeteria. Okay. All conventional heating they want to replace to induction heating. Okay, that is another problem. So this is just some glimpse of the work we are doing actually. Okay, not very easy job. Ground if you work, I think professor gets confused. Reality, but yeah, we have seen a lot of difficulty in village at least. But now we have overcome. Only thing is handing over. If that becomes smooth, then we can flag hoisting we can do. So just to conclude, your future distribution network or the smart distribution network will have a lot of renewables with the storage and then sensors, smart meters everywhere, communication backbone, automation at every stage, advanced management tools. Challenges to implement them will be there. Renewable integration will pose challenge of power management and stability. Microgrid concept will come because there is a strong policy which are in place. And strategic location like defense locations, institutional buildings, community level, microgrid will be formed. And finally, just game will change. They may participate in peer-to-peer trading also. They will be like a virtual power plant. Okay. In this project, we have demonstrated under rural or semi-urban and urban some of these smart distribution network along with integration of cyber infrastructure, cyber security, and EDMS. Rural specifically a new management model we have introduced, a new way to help them in generating the employment, local employment. Okay, thank you very much. I must thank support from different agencies for this project. Question?
Do you have any question? Sir, is there any pricing strategy for using electric vehicle as energy storage system?
Right now, no. But I think this will come again at distribution end. So once DSO is in place, they have to decide the pricing. Pricing will be decided by the regulatory commission, by the way. But right now, no, because it is not being purchased yet. I told you that vehicle doesn't have
Sir,
capability.
what challenges it may face?
Well, first of all, you have technology challenge. All vehicles should be V2G kind of capability, and then the regulatory commission, somebody has to approach, and regulatory commission will work out on that. Not challenges, it is a process. Yeah, but technology challenge is first. First of all, even conventional EV large deployment which we had planned is not happening because of charging infrastructure. We could not add. So you should have very large number of charging stations in place. Like if I am driving from here to Guwahati and in between battery gets discharged, so I should have somewhere charging station before that.
Sir, is there any possibility of wireless transmission, wireless charging of electric vehicle in India?
Well, that is also research is going on. There are already in few countries it is there, especially buses. So when they are passing through stoppage, so there is a rail having magnetic field, and through wireless charging, they get charged. So if they are standing for some time, they get charged. They are fast chargers. Okay. So research is going on. Actually, I am also part of one Ministry of IT and Information Technology Committee. There, one of the focus is this. CDEC is also trying to develop. So if you can contact CDEC, and if you have interest, if you have done some work, please let them know. Because this is one area we want to explore. Yeah. Wireless charging. Yeah. No question? Yeah.
Why government of India basically is not focusing compressed air energy systems?
I don't know really. Answer is not known to me.
Is there any technical challenge?
They say it is because of cost actually.
Cost.
Cost. They are not convinced with the cost. But I believe that nobody gave any concrete proposal to them. Somebody should come forward and give concrete proposal to them.
Any technical challenges?
No, cost is one challenge, but again, land is challenge. Land is availability of land. But again, I said that why not those defunct mining area, underground mining, not overhead, where a lot of empty spaces are there inside earth, which is dangerous to people. Sometimes they collapse, is it not? So utilize them. So, but I think the cost has to be worked out, and some concrete proposal should go. Okay. I believe so, because I could not get any convincing answer from government also. Okay.
Sir, you say in coming sometime the project will be finished and will be handed over. Sir, the real-time simulators and the lab setup you have.
No, lab setup will be with us. Our
What will be the researcher to, if they want to access, what will be the procedure?
okay. So go to this website, and you can see the resources lab demo. That also describes how to access us.
Okay.
Recently we have posted.
Okay, sir.
Very simple. You can write to the people and through your faculty and visit us. Use it. RTDS, actually first RTDS was set up by me with the IRFA funding from DST, almost 7 crore project. So we have kept it free for academic institute. There is a charging policy, but we are not charging to academic institute, students specifically. But now I have retired, so you can talk to the others. Yeah. But I think there is no difficulty. You can approach anywhere. Roorkee has this facility, we have, and I think RTDS is there even in Indore. They are having. I was in that committee who supported Indore. So many people have. But please write to us if you need it. And nearest is your, I think Kharagpur also has RTDS now. Opel RT they have, that much I know.
Sir, IIT Guwahati?
IIT Guwahati, no, I don't think so. I am not sure, yeah. You can check. Probably they don't have. Yeah. Guwahati doesn't have.
Anyone else?
Thank you, sir. May I now request coordinator of the program, Vijay sir, to present the memento as a token of love or memory from the Department of Electrical Engineering.
Please do write to me if you have any query later on also. So this is beginning relation with me. You can continue. My email is there in the presentation in the beginning. So please don't hesitate in writing. Just tell me who you are. So, he was my student. His wife was also.
So now is the time for PV. So you can take me. After that there are some sessions related to the ATAL activity like MCP there. Attendance mandatory.
Giving, sir.
And there are certain more documents. So I will discuss.
सेव कर लिया उसको
Vinay,
You take that and
copy, you have copied na? Results?
पीपीटी हटा दो पीपीटी नहीं यूज करना बिकॉज़ उसमें कई लोगों का एफर्ट है पीडीएफ पीपीटी वाला हटा दो चलो
PPT वाला कौन सा? New folder.
पीपीटी हटा दो इसको डिलीट कर दो इससे हटा क्योंकि इसमें कॉपीराइट
Okay, sir.
और ये यार वो भी ये पुराना है वो हटा ये हटा पुराना वो नया में
अच्छा, ये खुला हुआ है.
नहीं नया वाला पुराना
ये पुराना वाला था.
पुराना और उसमें जाओ रिसाइकल
Okay, sir.
ये इसमें यूएसए
सर बहुत सारा है. ये empty कर देता हूँ.
बहुत पर्टिकुलर
सर पेन ड्राइव.